Let's talk about rational numbers. Rational numbers you remember from your perfect quiz. They're right underneath real numbers on our graphic organizer. And underneath the word rational numbers, you guys wrote down that rational numbers could be terminating decimals or repeating decimals. So what we're going to be looking at today is those types of decimals, repeating and terminating decimals, and what they look like in fraction form. Now, I've listed 3 ways that I'm going to reveal one by one on how to do this. And the first way is actually to have some fractions memorized. You guys have a mean math teacher who's making you memorize some of the most common fractions, like this first one. 3/5 is a fraction you guys should all have memorized by now. The answer is 0.6. I didn't have to do any work here because I've already done the work by memorizing some really common fractions. Now, if you don't have a fraction memorized, maybe there's a fraction that you can convert to another fraction that you do know. For example, 1/20. I don't have 1/20 memorized, but I can see that if I multiply by 5, I'm going to get 100 here on the bottom. So if I multiply by 5 on the top, I get 5 out of 100, or 5/100ths, 5/100ths, and I know how to write that, 0.05. Now, if you have a fraction that you don't have memorized or that doesn't convert nicely, I don't have 5/6 memorized and I can't turn 6 nicely into a fraction I do know, then I'm going to divide. I'd like you to highlight this and make a note in your fraction that even though I listed this third, this is the way that always works. Dividing will always work. So 5/6, I don't really know how to do it. I'm going to go ahead and set up my division. 5 divided by 6. 5 divided by 6. Now, a lot of times students get these numbers backwards, so here's a quick way we can check to make sure we have it set up correctly. 6/6 would be a 1 whole. Anything smaller than this, like 5/6, that's going to give me a decimal answer. So when I go to divide, does 6 go into 5? No, it doesn't. That right there tells me that I've set this up correctly. I'm going to have to come up with a decimal answer. Now, if I accidentally set this up wrong, like some students might have done 5 divided by 6, this is wrong. I should see, does 5 go into 6? Yes, it does. It goes in once. Right away, I should be able to tell that that's wrong because I know my answer is going to be a decimal. It's going to be less than 1. So let's go ahead and continue with this problem. 6 didn't go into 5, so I'm going to have to add a 0 here. I can add as many zeros as I need. I don't know how many I'll need, but 6 goes into 50 8 times. 6 times 8 is 48. I've got 2 left over. I'm going to bring down a 0. 6 goes into 20 3 times. 6 times 3 is 18. I've got 2 left over. I bring, wait a minute, this is the same thing I got last time. At this point, I can see that this answer is going to have a repeating decimal in it. I'm going to keep getting the number 3 over and over and over again. So my answer to 5/6 is 0.83 repeating. Please notice that the line is only over the 3. The 3 repeats, but the 8 does not. Now we've got mixed numbers that we need to turn into decimals, and this is really going to follow the same process. The only difference is that mixed numbers have a whole number component that goes in front. So this will look like 3 point something. This will look like -4 point something. And this will look like 17 point something. Now all I need to deal with are the fractions. Well, lucky for you, your mean math teacher made you memorize 2/3. 2/3 is 0.6 repeating. So this answer is now done. 3/25. Now, I didn't have you guys memorize 3/25, but this is one of those fractions that you might notice. I can turn this into 100 on the bottom pretty easily. 3 times 4 gives me 12. Well, that's going to be 0.12. So my answer is -4.12. And on this last one, 1/6, you know, I don't know the sixths, and I didn't make you guys memorize them, so I'm going to do some division. And remember, division always works. 1 divided by 6. I'll know that I have this set up correctly if 6 doesn't go into this number. Does 6 go into 1? No. I know I put these numbers in correctly. 6 does go into 10 one time, with 4 left over. 6 goes into 40 6 times. 6 times 6 is 36. I've got 4 left over. I'm going to bring down, wait a minute. This is the same thing I got before, which means that this is going to continue to be 6's. So how will I write this decimal? It's 0.16 and the 6 repeats, so there's a line over the 6. 17.16 with a repeating line. Now we've got improper fractions that we need to turn into decimals. Now, these I like for you guys to try and do with mental math, but if you don't know how to do them with mental math, or if you find that a little bit challenging, you can always set them up by setting up division. How many times does 3 go into 11? 3 goes into 11 3 times. I know that because 3 times 3 is 9. Well, I was trying to get to 11 and I only got to 9, so how many pieces are left over? 2. The denominator stays the same. And as a decimal, the whole number 3, and here's one of those fractions you guys are lucky to have memorized, 2/3, 0.6 repeating. Now, if this doesn't make sense, remember that division always works. 11 divided by 3. 3 goes into 11 3 times. I've got 2 left over. I need to continue, so I'll add a 0. 3 goes into 26 times. 3 times 6 is 18. I've got 2 left over. I'm going to bring this down, and wait a minute, that's the same thing I got last time. This 6 is going to continue on, which means that my answer is 3.6 repeating. Let's go ahead and look at this next problem. 25 goes into 110 4 times. 25 times 4 is 100. But I was trying to get to 110, which means that I've got 10 pieces left over. Well, this fraction can be reduced by 5. If I divide by 5 on the top and bottom, 10 divided by 5 is 2. 25 divided by 5 is 5. And lucky for you guys, all those fractions you memorized, 2/5 is 0.4. So far I haven't had to do any division yet. Let's check this last problem. 6 goes into 14 2 times. 6 times 2 is 12, but I was trying to get to 14. So that must mean I have 2 pieces left over, and the denominator is 6. I can reduce to 6 if I divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Oh, you guys, one more question you already know the answer to. 1/3 is 0.3 repeating. Now we're going to go the other way, changing decimals into fractions or mixed numbers. Here's how we're going to do this. We're going to count the digits behind the decimal. 1, 2. 2 digits behind the decimal. That's how many zeros I will need in my denominator. I know I'm trying to make a fraction, so there's my fraction bar. And I've just figured out that I need 2 zeros in my denominator. So my denominator will be 100. Use the digits as the numerator. These digits will become my numerator. 32 over 100. And my last step, hopefully you were able to guess, it's reduce if it's possible to reduce. Now 32 over 100 isn't an incorrect answer, it's just not complete. I can reduce 32 over 100. I can divide both the top and bottom by 4, which will give me 8 over 25. Let's go ahead and try this next problem using the same steps. Count the digits behind the decimal. 1, 2, 3. That means my denominator will have 1, 2, 3 zeros in it. Use this digit here as the numerator. And reduce if I can. Well, I can divide both the top and bottom by 5. 1 over 200. This last question is an example that will be a mixed number. How can I tell that it's going to be a mixed number? Because I've got a whole piece out here. So my answer is going to be 1 and some fraction. Well, let's just deal with the fraction. Count the digits behind the decimal. There's 1. So that means on the bottom there will be 1 0. 0.8 is 8/10, and hopefully that's one of those ones you have memorized. Hopefully you also know that 0.8 is 4/5. That's one of the ones you had memorized. So your final answer should be 1 and 4/5. Now this page is for those of you looking for a challenge. There is a way to come up with fractions for repeating decimals, and that is that the denominators, instead of having 10 or 100 or 1,000, there's going to be 9s on the bottom. So we're going to do the same thing. I'm going to count how many digits are. There's 1 digit. So on the bottom of my fraction, there's going to be 1 9. I put this on the top. I reduce. And I see that 3/9 is 1/3. Let me go ahead and prove to you on a calculator what this looks like. 1 divided by 3, there it is, 0.3 repeating. Let's check this next one. I'm going to count how many digits there are, 2. So that means on the bottom, I'm going to have 2 9s. I'll put that 42 on the top. And then I'm going to reduce. I can actually reduce both the top and bottom by 3. 99 divided by 3 will be 33. 3 goes into 4 once, 1 left over. 3 goes into 12 4 times. Let's check on a calculator. Prove to you that this works, that this is correct. 14 divided by 33. There it is, 0.42 repeating. And let's try one last problem. I've got 2 digits behind the decimal. That means there's going to be 2 9s on the bottom. I put this on the top. Hopefully you can see that I can reduce the top and bottom by 9, which is going to give me 1/11. Let's check one last time on our calculator. 1 divided by 11. There it is, 0.09090 repeating. This is a very cool game that will ask you to convert common fractions into decimals, just like you've learned for your perfect quiz. tinyurl.com/carnsdecimals. And there's a second game that will ask you to sort a whole bunch of numbers into 2 baskets to say whether they are rational or irrational. The faster you sort them, the better your score is. tinyurl.com/carnsrationalnos, which stands for numbers.